This is linear algebra. I'm gonna introduce how gonna find the orthogonal basis by using Gram-Schmidt process. So this one is Gram-Schmidt process. This algorithm introduce how you're gonna create orthogonal basis for any non-zero subspace. So here is a process algorithm itself. When you given the x1, x2, xp, any base, any base, you're gonna create orthogonal basis for the subspace. So V1 is x1, V2 gonna be x2 minus x2 times V1 divided by V1 times V1. That's the scalar component times V1 vector. That's the you create V2. You do the another process V3, x3 minus x3 in a product V1, V1 in a product V1 and V1. That's the component for the V1. Component for the V2 gonna be x3 V2, V2 in a product V2, so on. So you created V1 VP. This one, V1, V2, VP, is orthogonal basis for the subspace. Also, this V1, V2, you're going to span V1, V2 exactly same subspace spanned by X1, XP. Let's just see this example. So span x1, x2 is a subspace W, linear combination of x1, x2 gonna be W, right? Then x1 is given like this. This vector is R3. We're gonna create orthogonal bases by using the Gram-Schmidt process. That's the algorithm. So how can create the V1? V1 gonna be just x1 first vector. That's the x1. Let's go to the V2. What is V2? V2 gonna be x2 minus x2 V1, V1 inner product V1, that's the x1. That's gonna be V2 vector, but V1 is x1. This one gonna be changed. This one is x1. This one is x1. This is x1. Let's find the inner product first. So let's find x2 inner product. x1 gonna be 3 plus 12 plus 0 is 15. x1 inner product x1 gonna be 9 plus 36, that's the 45. So you find the V2 is x2 vector minus scalar component gonna be 15 over 45 x1. So this one is x2 minus 1 over 3 x1. That you find it. Specifically V1 is x1, x1 is 3, 6, 0. V2 gonna be x2, x2 is gonna be 1, 2, 2, 1, 2, 2, minus 1 over 3, 3, 6, 0. This case is 1, 2, 2. That vector gonna be 1, 2, 0. This is gonna be what? You're gonna find the 0, 0, 2. That's you're gonna find the orthogonal basis. V1 vector, V2 vector is on orthogonal basis for W. You can check V1, V2 is orthogonal. How gonna check it? Inner product. V1 inner product, V2 gonna be 3 times 0 is 0, 6 times 0 is 0, 0 times 2 is 0, that's the 0. So you created orthogonal basis for the subspace W. We have practice problem for the Gram-Schmidt process. Let's have this question. They said we're going to find the orthogonal base for the column space. So we have find the column space first. X1 is first column, negative 1, 3, 1, and 1. Second column, 6, negative 8, 2, and negative 2, negative 4. Third column, 6, 3, 6, negative 3. So we want to find the orthogonal basis for this column space. So let's find the V1 is x1. V2 gonna be, what is V2 gonna be? X2 minus x2 inner product V1, V1 inner product V1. That's gonna be x1. That's the first thing. So x1 is V1, guys. So I'm gonna write down this one is V1. V3 gonna be, how can I find V3 is x3 minus x3 inner product xv1. Then you're gonna do v1 inner product v1. That's gonna be v1 minus x3 inner product v2, v2 inner product v2. That's gonna be v2. That you're gonna find it. That's the Gram-Schmidt process. So let's go to first one. V1 is x1. So x1, we find it already. -1, 3, 1, and 1. Let's the V2 vector. V2 vector, you're gonna see x2 inner product V1 first, x2 inner product x1. So x2 inner product x1, that's gonna be -6, -24, -2, -8. So you have this one is gonna be -36. Next one is V1 inner product V1. Another way x1 inner product x1. That's gonna be 1 plus 9 plus 1 plus 1. That's the 12. So you find the V2 vector right there. X2 minus 36 over 12. That's V1 vector. V1 is x1. That's you write it. So you do this one, x2 plus 3x1. That's the V2 vector. So how can find it? X2 vector gonna be 6, -8, -2, -4 plus 3. X1 vector is -1, 3, 1, and 1. So you find it. This one is 3. This one is 1. This one is 1. This one is -1. That you find V2 vector. Okay, last one, V3 vector. We want to find V3 vector right there. V3 vector, you have find x3 inner product V1 first. x3 inner product V1 is x3 inner product x1. The x3 is right there, x1 is right there. Inner product gonna be -6 plus 9 plus 6 -3. This one is 6. Okay, second part, we did this one. Now V1, V2, V1, V1 already did it. That's the 12. V1, inner product V1 is 12. Let's go to the X3, inner product V2. X3 inner product is X3 is right there. V2 is right there. V2 is this vector. So that's gonna be 18 plus 3 plus 6 plus 3. So what I have here, that's gonna be 30. Guys, you see that? X3 is right there. V2 is right there. That you have it. So now we have find the V2 inner product of V2. That's the V2 is right there. Here is 9 plus 1 plus 1 plus 1. That's gonna be 12. So you find the V2 vector, V2 vector, V3 vector, V3 vector x3 minus here x3 inner product V1. That's gonna be 6. Then V1, V1 inner product 12. That's the V1 minus x3 v2 is 30. v2 inner product v2 is 12. That's the v2. That you find it. Okay, let's go here. v3 gonna be x3 minus 1.5 v1 minus 5 over 2 v2 vector. So let's find the x3. x3 vector gonna be, what is x3 vector? 6, 3, 6, negative 3, minus 1.5. v1 vector is x1, negative 1, negative 1, 3, 1 and 1, and negative 5 over 2. v2 vector gonna be 3, 1, 1, negative 1. That you find it. So you're gonna do all those subtractions. 6 minus plus 1.5 minus 15 over 2. Next one is 6 minus 3 over 2 minus 5 over 2. 6 minus 1.5 minus 5 over 2. Last one is negative 3, negative 1.5, positive 5 over 2. After you simplify this one, you're going to have negative 1, negative 1, 3, negative 1. So now 3 vector, v1, v2, v3 is on orthogonal basis. Column A. So this one is really easy way to find the orthogonal basis.